Hey guys, back here in the garage working with some simple machines, and I just wanted to show you a few things that we're working with here. Here's one thing. We'll be dealing with this wood and using these hooks on our next assignment and our next activity. So if we remember from simple machines, those hooks are going to help us determine and help us measure work using the pulley. So take a look at this here. Here's another very simple machine that we're going to be using today. It's got some levers. You guys are familiar with the other radial arm saw. This one is just a much smaller version. I know it's a little dark. I apologize for the lighting, but this is where we're at right now. I'll catch you up when we are almost done. Hey guys, we're back here in the workshop. So I'm going to explain to you exactly what I'm going to be doing here with the measurements, first and foremost. So the idea that I have here in my head is that there's going to be 2 feet that stick out like this, 1, 2, where we're going to place books on. Then there's going to be a 1-foot pole, and then a pole off that pole that's going to measure about 6 inches. So your hook and your pulley will hang off this pole, and that's where you're going to be measuring your work from. If you look right over here, we have the board that we're actually going to use. I'm going to go ahead and engage the saw now, and I'm going to show you how I do that. And then I'm going to do my other 1-foot cuts. Pay close attention here. Notice I have my safety gear on. So I'm wearing some goggles, I'm wearing some gloves. This is nighttime, so I'm using the clear ones. Here we go. Very good use of a simple machine, wheel and axle, and then the saw, which are a bunch of mini wedges to accomplish this task here. So I'm going to go ahead and cut my 1-foot pieces now. Follow me over this way, grab my tape. Look close here. 1 foot's about 12 inches. So I'm going to go ahead and get that 12-inch cut now. This makes real quick work of this, so I don't have to waste too much time putting down marks or anything like that. So with this is going to be this is kind of a rough cut. It's not a super precision job. This frame is just going to be holding your simple machine that you're going to be measuring the work with. So it's the machine that really needs to be precise. And our measurements, right? So we're going to be measuring work in joules and using spring scales to get the newtons of how much force we're exerting, and use a tiny equation where we multiply the force by the distance, and that should get us our joules. I will also show you another equation called mechanical advantage, and we'll discuss that more in depth in class. If I were to be able to attach something to measure force here, I'd be able to know how much work is being done. And if I were to attach something to measure force in a handsaw, I'd be able to compare the two, and we would have our mechanical advantage. I'll be back with you when I'm putting this together. Hey guys, we're back here in the workshop. Take a look down here at what I've got. So I've got my hand-powered, or my electric drill, evolved from the hand-powered drill, though it does the same operation, the screw. So that's what we're going to use. Go ahead and get a close-in on this. We're going to go ahead and use this screw to hold something together. So this simple machine in this instance is going to hold something together, and what it's holding is this arm that's going to be holding your pulley. So I'm just going to go ahead and run it in. Very carefully doing so. Oh. Go ahead and cut. So here we are fastening the arm that's going to hold the pulley using the screw, which is one of our simple machines. But in this way, we're using it to hold something together rather than to move anything. So here's the arm. As you can see, we're going to go ahead and attach this arm very carefully to this arm from the top. So what I'm going to go ahead and do is follow me this way. We're going to follow me this way here. We're going to move it to the vise. So this operation is also a screw that produces gripping force. So I'm going to use this vise to hold my work in place, hold my design in place with the power of the screw. So I'm using the power of this screw here to hold this in place while I run the nails from the top. So go ahead and turn around. I'm running the nails through here. I'm using our air-powered hammer, which does a lot more force. It uses a lot more force to do more work. Here we go. 1, 2, 3, And let's try a couple more just for safety. That should hold that nice and tight. Right here. Now I'm going to go ahead and add this support. And this support here is going to hold our arm from collapsing under any weights that we might be experimenting with in class. So the idea is I'm going to run the nails through here. They call toenailing, which should hold this board in place. And then toenail it this way, which should hold this board in place. Now if you come on this side, you can see a small mistake I made here. They call this a shiner. And when you run a nail through and it doesn't quite meet all wood and it comes out, we call this a shiner. So I'm going to file that down for safety purposes. And the easiest way to do this is by using something like this. Now these are two levers. This is one type of lever. Here's your fulcrum. And as our levers move, they create force. In this case, a cutting force. So I can use that to cut and snip this so it does not become a problem or harm anyone in class. I'll be back to you in a sec. Alright guys, here we are at the last part. We're assembling the last piece that's going to hold this in place and hold your pulley here so we can measure our work. So the idea is that I need to attach both of these together. And the best way I've found to attach them is to put them both in this vise, hold them in place, and just hold them straight together. Let's get these flush, which is what they call when the wood is smooth and not uneven on flat surfaces. So that term is called flush. Once we get them flush, take our pneumatic nail gun here and fire in a few rounds here. Now if you can hear that air, it's coming out at a high velocity to really push those nails through in one strike. Much, much faster and much more efficient than a traditional hammer. Here's our last piece that's going to hold our contraption in place. This should effectively strengthen our contraption and make it so we can hold up to 5 kilograms, because that is the highest weight that our spring scales will record. And there you have it. The thing that is going to hold our pulleys in place while we do our job. Alright, thank you guys for watching. I hope you enjoyed this, making our contraption to hold the pulley. That's what I'll be naming the video. If you liked it, please hit that like button and go ahead and click subscribe, especially if you're one of my students, so that you get all this information of the things that are coming up within the week. Alright, signing out until we see you again for the actual activity.